So here is how Ian Goodfellow defines deep learning. The idea is to allow computers to learn from experience and understand the world in terms of a hierarchy of concepts, with each concept defined through its relation to simpler concepts. So if we pay focus to the first line, so allowing computers to learn from experience is nothing but referring to the training part, right? Feed computers or machines a lot of training data where they can learn certain things about the world and understand the world in terms of a hierarchy of concepts. All deep neural networks try to break down information and representation into hierarchical information or into hierarchies. So the idea is, so when CNNs say that I want to have deeper and deeper convolution blocks, they mean that the information or the representation that is captured in images is not one shot. It is hierarchical information, and I want to understand the hierarchy. For example, the top level features, the mid level features, and the low level features, right? First I want to understand the dark spots on the face, then I want to understand the maybe the structure of the nose and the ears and the symmetry of the face, then I want to understand the facial morphology of the face, right? So this is the way, this is what hierarchical literally means. Even in language, when we say we want to have multi-headed attention, we want to understand different hierarchies in the language, or information at different hierarchies. For example, how a subject is related to a noun, and how that is related to a verb, and how that is related to an adjective. What are the syntactic and semantic relationship between the tokens? And digging down and deep the language at multiple hierarchies to make sense of it, right? Because only at one level you might not understand information. All the information in the world is hierarchical, and these deep neural networks have cracked that idea, right? So that's why we have to understand the world in terms of a hierarchy of concepts, with each concept defined through its relation to a simpler concepts. Now, this was the first line in the book by the main OG, Ian Goodfellow. So the deep learning book. Yeah. So this is how he defines deep learning. Now let's read a little more. By gathering knowledge from experience, this approach avoids the need for human operators to formally specify all the knowledge that the computer needs. Now, what he tries to mean here is that if you go through the training route where you are asking the model or the computer or the machine to learn from its experience, then you would not have to formally specify all the rules and help the computer memorize information, right? The hierarchy of concepts enables the computer to learn complicated concepts by building them out for of simpler ones, right? So hierarchical information, hierarchical representation of features, hierarchical understanding of concepts helps the computer to simplify things. If we draw a graph showing how these concepts are built on top of each other, the graph is deep with many layers. Now, what he's trying to signal is that in order to represent the machine, if I try to, if I try to draw the topology of a graph, and it's all built on top of each other, the graph is going to be deep and with many layers, right? So that is why we call it, or we call this approach as deep learning. So I mean, this is also pretty straightforward. Now he gives a very classic example around representation learning. Let this session be around talking about AI literature, where we define deep learning with Ian Goodfellow's words, and we define representation learning. Okay, so now the idea is, he gives an example. What if you were to write a program that could recognize a car, right? That could recognize an image which has a car basically. So the input is an image, that image has a car, and you have to recognize it, right? Whether the object in the image is a car or not, right? So what would you do? To recognize a car, you need the ability to be able to recognize a wheel. Now, to recognize a wheel, you might need the ability to recognize spokes, right? Spokes in the wheel, and maybe the fender in the car. But it's very difficult to capture the idea of a wheel only in pixels, right? So what do we do? So he proposes an idea of something known as representation. What if you could produce, hand or hand coded or hard coded representation? Okay, that's not really useful. But what if we could have some representation of car that computer can understand, and then maybe we can map that representation to the output? But that is also not efficient. What is efficient is when we can learn these representations. Mapping representation to the output answer is not the most efficient idea. But what if we could learn the representation and the computer could produce its own representation of the car that it can learn itself and then come up with an output. So this approach is also known as representation learning. So his argument for learning representations and letting the computer produce its own representation that is better for the output is that if we stop the human intervention of producing and coming up with with a representation, we can scale it. We can scale this particular system across multiple tasks, right? And we can also aim to produce better and better representations through this learning process, which is fair, right? Because in machine learning, the representation was referred mostly to as feature engineering. But deep learning or the deep neural network says that let me produce my own representation of this particular modality, whether it is an image or text. I will produce the representation such a way that I keep on minimizing my cross entropy or mean squared error loss. So wherever my loss is minimum, that is my optimal learned representation, and I will learn the representation in higher dimensions, right? Now learning that representation in higher dimension is basically mapping your input data in whatever modality and whatever dimensions you have and taking it to a higher dimension data and then learning those representations through weights and parameters, right? So or through weights and biases, weights, parameters, biases, all of things point to one and the same set. And the learned representation would anyways produce the best output because you are optimizing loss along the way while you're learning. So this whole process is describing the nuance of training a neural network in a philosophical way. Okay, so one paradigm that is described for deep learning is representation. Then there is another strong perspective that he has described. Hear me out. So another perspective on deep learning is that depth enables the computer to learn a multi-step computer program, right? So till now we have been talking at an abstract level, which is representation. Now we're going one level below, where we're talking about depth of the neural networks, right? And we are kind of favoring the idea of depth. Each layer of the representation can be thought of as the state of the computer's memory after executing another set of instructions in parallel, right? So what he's trying to signal that each layer has its own significance in producing the representation, and they're all tied sequentially. Networks, deep neural networks with greater depth can execute more instructions in sequence. We know that, right? So in a parallel distributed processing, they have the ability to learn or to possess intelligent behavior, especially when they're networked together, right? So this also applies in biological neurons because our brain has a lot of biological neurons, and this gave rise to the idea of hidden units in the computation in the deep neural networks. Now, after knowing all of these jargons and terms that we have been hearing throughout, if we try to map out how all of these can be put together in a Venn diagram, so the largest umbrella is the AI umbrella, right? So one of the examples that he gives in the AI umbrella is the knowledge base. Then underneath the AI umbrella is machine learning umbrella. So then there the example is the classical machine learning algorithms, for example, logistic regression. Then we have one level beneath it is representation learning, right? For example, shallow encoders, shallow autoencoders. Then we have something which is known as deep learning. One of the example in deep learning is the deep neural networks, multi-layer perceptron. Now, one more definition that I would like to learn from Ian Goodfellow and how he defines that particular idea, which is nothing but reinforcement learning. Because reinforcement learning you know, has been a key idea in today's modern AI world, especially when we have AlphaFold and AlphaGo. In his words, he says that another crowning achievement of deep learning is its extension to the domain of reinforcement learning. In the context of reinforcement learning, an autonomous agent must learn to perform a task by trial and error. We know that whenever we introduce reinforcement learning, the idea of an agent comes into picture where we put an agent into an environment, right? So today we are thinking about AGI. We always are thinking about world models and especially the project Genie, which is capable of generating environments. And those environments can act as a training ground for training agents to produce human level intelligence. So the simplest or the smallest idea of reinforcement learning was also the same. What if we can have an agent right? And now this agent is put in an environment, and the agent is trying to learn a task, a deterministic task, and it's trying to come to a winning situation in that deterministic task by trial and error, by again trying and erroring without any guidance from the human operator. The human is not guiding, right? That you should take this move, you should take this move. There is no tree based Monte Carlo search or any tree based search that the human is presenting the agent to. The agent is trying to learn from its trial and error without any guidance from the human operator. So DeepMind, we have seen that DeepMind demonstrated that reinforcement learning system, especially based on deep learning, is capable of playing Atari video games. It's capable of playing chess. Is also capable of playing AlphaGo, right? So I think this video was fun and light, where we could define formally the idea of deep learning, then the idea of representation learning, and the idea of reinforcement learning.